Okay, this is example number 2. Okay, that we're going to do now. So axial load of magnitude of 175 kilonewton are applied to a row steel column of this size. I think I have it. Yep. And given that E is 12 millimeters from geometric axis, and knowing that, okay, the yield is 250, the E is 200 gigapascal, determine the factor of safety with respect to yielding. So we're going to use a chart. Okay, I'm teaching with. So when you use this chart, you have to be careful what controls the magnitude of this chart. Again, it's units, which is in SI, down here is megapascal. Again, if it's in PSI, you have to use a chart that's in PSI. And then you have your E and your U. Okay, so this U and your E are the magnitude. So what we're going to find now, okay, we are going to find our L over ER, and then we have to find our EC over R squared. Then we can relate to our P over A. And then with our P over A, we are given the load. Okay, we're given the load of 75. And then we can calculate our area. Okay, and then we go from there. Right, so the first thing we're going to do is we are going to look at our structure. Okay, so our structure will buckle in this direction, right? So when it will buckle that direction, I know this transformation is different from here, right? So you have to be careful. But the way it's buckled, it will buckle about the y-axis. Okay, so we will buckling, or if I write down here, right, from here we know that buckling will occur about the y-axis. So when that's the case, you have to use this set of values over here, right? So we are given that P is equal to 175 times 10 to the power 3 Newton, and then the A from the table is equal to 570, well 5,700 millimeters, or 5700 times 10 to the power minus 6 meters squared. Okay, then Ry will be equal to 34.8 times 10 to the power minus 3 meters. Okay, so Le over L, or our equivalent load, is equal to L. Why? If you look at our structure over here, both ends are pinned. Okay, so both ends are pinned. And then from here, we know that Le is equal to 3.8 meters. Okay. So in order to use the chart, right? In order to use the chart, right? In order we must find, okay, we must find the following magnitude. So what we need to find is Le over R, and we also have to find our EC over R squared. So we have them. Okay, we have them. So Le over R, right? We know our Le is 3.8. We identify our radius of gyration is 34.8 times 10 to the power minus 3. So this will be equal to 109.2. Okay, so this is on our x-axis. Right? Then we have to find our EC over R squared. So we are given our E, our offset is 12 millimeters. Now the C, right? The C over here, so we know that it's about the we are going to focus on the buckling will occur about the y-axis. So this over here is our C. Okay, so it's BF, which is equal to BF is equal to 148 or 0.148 divided by 2, and then your radius of gyration is 34.8 times 10 to the power minus 3 squared. So this will be equal to 0.73325. Okay, so this is our curved coefficient. So what we do now, so we're going to draw a line 109. So this is my 109.2, just eyeball, okay? And then over here, this is our 0.6, and this line over here, so this line over here corresponds to our 0.6. This line over here is 0.8. So I eyeball the cross based on LE over R and based on the curve, right? I'll draw a horizontal line across, and this again I'm just going to eyeball it. This is 90. Okay, so from the chart, right, it's just an estimation. So PCR over area is equal to 90 times 10 to the power 6 Pascal. Okay, so the critical load, right? So you can take the 90, right? So the critical load, the PCR, is equal to 90 times 10 to the power 6, given the area that we have calculated or that we get from the chart is 5700 times 10 to the power of minus 6. So this will be equal to 513 times 10 to the power 3 Newton. Okay, this is what, so 90 power 6 times 5700 power minus 6 is equal to 513 times 7. So the factor of safety will be equal to the critical load divided by the P allowable or the applied. So it's 153 times 10 to the power 3 divided by 175 times 10 to the power 3, because that's the applied load. Alright, so the applied load is at 175. So from here, this will be equal to 2.93 factor of safety. Right, that's all for buckling that we're going to do. Now, buckling is going to be critical for almost all of you, because you will have a lab that is going to deal with buckling. And please watch my notes again or my videos again when you are doing the lab. Thank you. Bye. Have a great term ahead.